Hello, how to solve n times n times n, and this equals 27 divided by 8, solving for all values of n that satisfy this equation. So n times n is n power 2 times n, that is n power 3, and this equals 27 divided by 8. So from here, I have n power 3 equals 27. I can have it as 3 power 3 divided by 8 is 2 power 3. Now, if you have a power c divided by b power c, this is a divided by b raised to the power of c. So from there, we have n power 3 equals 3 divided by 2, and this is raised to the power of 3. So we move this over here, solving for n. We have n power 3, this is minus 3 over 2, and this is raised to the power of 3, and this equals 0. So right now, we have power 3 here, we have power 3 here, we have minus here, we can expand, and if you have a power 3 minus b power 3, this is a minus b times, we have a squared plus ab plus b squared. Now our a is n, and b is 3 over 2. So we insert a, n, and 3 over 2 for a and b. So what we are going to have from here, we are going to have n minus 3 over 2 times, this is n squared, plus n times 3 over 2 plus 3 over 2 raised to the power of 2, and this equals 0. So from here, we have n minus 3 over 2 times n squared plus n times 3, that's 3n over 2 plus this, we simply have 3 power 2 divided by 2 power 2, and this equals 0. So from here, I have n minus 3 over 2 times this is n squared plus 3n divided by 2 plus 3 power 2 is 9 divided by 2 power 2 is 4, and this equals 0. So we can equate each of these to 0. I have n minus 3 over 2 equals 0. I also have n squared plus 3n divided by 2 plus 9 over 4 equals 0. So to solve these individual equations, starting with this, for the first one here, I move this negative 3 over 2 across here. I have n equals 3 over 2. So right now, this is our n1. We need to solve this quadratic equation to find the other values of n. So what I'm going to do will be to find the LCM. This is n squared plus 3n divided by 2 plus 9 divided by 4 equals 0, and this is over 1. So to find the LCM here, which is 4, I have 4 divided by 1, 4 times n squared is 4n squared plus 4 divided by 2 times 3n. This is 6n plus 4 divided by 4, 1 times 9. This is 9 equals, this also is over 1, 4 divided by 1, 4 times 0, this is 0. Right? So we can cross multiply. So the whole of this will multiply 1, which will be 4n squared plus 6n plus 9 equals 4 times 0, that is 0. Now we are going to solve this quadratic equation to find the other values of n. And we are going to solve it using the formula method. So we write the formula in respect to n. So this is b squared minus 4ac then divided by 2a. So right now, we can find the value of a, b, and c. A equals 4, b equals 6, c equals 9. Remember, the 4 is the coefficient of n squared, that is the a here. B is the coefficient of n, that is the 6, and c is the 9, that is the constant. So we insert these values for the variables here. We have n equals negative p, that's negative 6 plus or minus square root of, this is 6 power 2, minus 4 times 4 times c, that is 9, divided by 2 times 4. And from here, we have n equals negative 6 plus or minus square root of, this is 36 minus 4 times 4, 16 times 9, that is 144, divided by 8. So from here, I have n equals negative 6 plus or minus square root of 36 minus 144. This is negative 108 divided by 8. So from here, we have n equals negative 6 plus or minus square root of negative 1 times square root of 108 divided by 8. So from here, we have n equals negative 6 plus or minus square root of negative 1 is I times square root of 108, that is 36 times 3. So this is divided by 8. So from here, we can have n equals negative 6 plus or minus I times square root of 36 times square root of 3 divided by 8. So from here, we have n equals negative 6 plus or minus I times square root of 36, that is 6 root 3 divided by 8. So 2 can divide this 3, to divide this 3, to divide this 4. So from here, we can have n equals negative 3 plus or minus I times 3 root 3 divided by 4. So I can factor out 3 over 4. That's n equals 3 over 4 times negative 1 plus or minus I times root 3. So we have two complex values for n. We have n2 equals 3 over 4 negative 1 plus I root 3. We also have n3 equals 3 over 4 of negative 1 minus I root 3. So these are the two complex values for n. And we also have one real value for n, which is n equals 3 over 2. And we are going to substitute that for n in this equation. So we have check our n is 3 over 2. So we have n times n times n equals 27 over 8. So this is 3 over 2 times 3 over 2 times 3 over 2 equals 27 divided by 8. So let's multiply the numerator. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 this is 27 divided by 2 times 2. 4 times 2 divided by 8 equals 27 divided by 8. So this shows that the real value here has satisfied the equation. You can as well test for complex. You can do that kindly drop down in the comment box. Thank you and goodbye.